Welcome to the root test for convergence. So the test states that if we have sequence a sub n, a positive sequence, then if the limit as n goes to infinity of a sub n raised to the 1 over n, in other words, the nth root of a sub n, if this limit exists and is less than 1, then the series, that is the sum from n equals 1 to infinity of a sub n, converges. On the other hand, if the limit as n goes to infinity of a sub n raised to the 1 over n, if this limit exists and is greater than 1, then we have the series diverges. And just like with the ratio test, if the limit happens to equal 1, so if the limit as n goes to infinity of a sub n raised to the 1 over n equals 1, then once again, we need a different test. So sort of understanding the test, why it works the way it does, we can pull a very similar trick to what we pulled for the ratio test. So if the limit as n goes to infinity of a sub n to the 1 over n exists and is less than 1, then that means that we can find some r such that a sub n raised to the 1 over n is less than or equal to r. And I should specify we can find, I didn't actually write out the word find. We can find r less than 1 and between 0 and 1, such that a sub n raised to the 1 over n is less than or equal to r. So that for large n. So that means that a sub n is less than or equal to r raised to the n. So again, we have our a sub n is trapped below a geometric sequence. So our sequence a sub n is trapped below a geometric sequence. With absolute value of r less than 1. So that means that our a sub n has to converge since the geometric series converges. Similarly, if the limit as n goes to infinity of a sub n raised to the 1 over n is equal to some L greater than 1, then that means that we can find r greater than 1 such that a sub n raised to the 1 over n is greater than r, or greater than or equal to r, for large N. And once again, that means that a sub n is greater than or equal to r to the n for large N. So our sequence a sub n is above a geometric sequence. So our sequence a sub n is above a geometric sequence with r greater than 1. So a geometric sequence with r greater than 1 diverges. It's trapped above that. That should also diverge. So again, here we have trapped below a geometric sequence with absolute value r less than 1. We know that this converges. And the geometric sequence with r greater than 1, we know that this geometric sequence diverges. So if we have a diverging sequence below our sequence must also diverge. So a very similar argument for the root test as we had for the ratio test, but our limit that we're taking looks fairly different. So in the next video, we'll go ahead and do a couple of examples where we can use the root test. And then once again, we'll also look at some cases where the root test tells us nothing.